Okay, continuing on with section 2.1. Okay, we have a function that is quadratic, and we're looking for what will be the minimum or maximum, and essentially what will be items that will stem from the coordinates of the vertex. Now, we have in standard form this given quadratic function, and to find out the minimum or the maximum, we want to translate this function in terms of its vertex form. So, starting out, if I separate the variable terms apart from the constant, so I have the quantity of negative 2x squared plus 16x, followed by the subtraction of 35. And in the parentheses, I want the first term to be x squared, so I'm going to go ahead and factor out the negative 2. Negative 2 into negative 2x squared is x squared. Negative 2 into 16x is going to be minus 8x. Again, we have followed by the subtraction of 35. And crossing over to what we have with the complete the square stage. Alright, so first term in the parentheses, we now have an x squared. And in the completion of the square process, if I take half of the coefficient next to the first order variable, okay, so I have negative 8 halves becomes negative 4. Negative 4 squared becomes 16. And now, for what we have with f of x, we're now going to have negative 2 times the quantity of x squared minus 8x. And in the parentheses, I'm going to add 16. And to keep everything in balance, okay, as I'm adding 16 within the parentheses, I'm actually, instead of adding 16, I'm going to be adding negative 2 times 16. And so we have at the front, we have negative 2 times 16 is going to be negative 32. And to keep things in balance, I'm going to offset the subtraction of 32 at the front by adding 32 at the end. And we have, in this case, all right, we have with f of x, and we have f of x equal to negative 2. And for x squared minus 8x plus 16, okay, again, this will be a squared trinomial where we have the square of x minus 4. Negative 35 plus 32 is going to be negative 3. And we have with what's going to be the vertex, okay, your h value is going to be at 4, and the k value is going to be at negative 3. So we have, and we have with the coefficient a, which is going to be at negative 2, and because we have a negative sign, that means that the graph opens down from the vertex. And the vertex, which is hk, so we have the vertex 4, negative 3. Okay, because it's opening down from the vertex. Okay, a vertex can be the top point, so this would be the maximum location. All right, so for what we have in this case, all right, so does the function have a minimum or maximum value? In this case, it's going to have a maximum. And in terms of what the function's minimum or maximum value is going to be, that's going to be the y or the k coordinate. So that is going to end up at negative 3. And in terms of where the minimum or the maximum value occurs, well, the maximum is going to occur at x is equal to 4. And upon checking, and we have the correct result. Okay, for the fifth problem, okay, we have a vehicle factory which manufactures cars. The unit cost depends on the number of cars made. Okay, and we have C to represent the number of cars. Okay, so we have for the fifth problem, okay, we have a function C of x, okay, and C is equal to the cost. X is in reference to the number of cars. And we have the unit cost, C, okay, depends on the number of cars made. And we have X cars made. And we have X number made, then the unit cost is given by, once again, this formula. And we're asking what the minimum unit cost is going to be. And it says to not round the answer. And now the minimum is going to be the vertex of this function. And if I rewrite what I have here, so this formula is in standard form. And if I separate the variable terms apart from the constant, okay, and what I want to do, okay, is that, again, I want the first term to be x squared, so I can move the 0.9 over, factoring out, and we have, with 0.9 factored out, we have x squared, and negative 306 divided by 0.9, okay, so that's going to be at 340. So you have the quantity of x squared minus 340x. And we have plus 36,001. And crossing over to what we have with the completion of the square. So I'm going to take half of negative 340 and square half of negative 340 is negative 170, and squaring out, okay, so you had 28,900. So for what I'm going to have for c of x, I will have 0.9, and I have times quantity, so we have x squared minus 340x plus 28,900. I'm going to create a little bit of space here. And again, we have plus 36,001. And now, upon adding 28,900, what I'm actually adding instead is going to be 9/10 of that. So I have at the front, so we have 0.9 times 28,900. So we have 26,010. So I'm adding 26,010 at the front, and I'm going to take away the same amount. So, what I have for c of x, I will have 0.9 times the quantity of what is going to be x minus 170 squared, and we have 36,001, take away 26,010, so I'm looking at 9,991. So for what we have here, A is equal to 0.9, and we have for the H value, okay, that's going to be 170, and we have K is equal to 99.91. So we have 170 cars, and the minimum cost, or per unit cost, okay, is going to be at $9,991. So in terms of, for lack of a better term, for optimizing, okay, for the minimum cost, this would be exactly at 170 cars manufactured, and the per unit cost we have at $9,991. And just going back and checking, so the unit cost, we have $99.91, and as I check, and we have the result to be correct.